What I'm looking at is some sort of hardware setup, which appears to have a few things. There's definitely some kind of electronic or mechanical components there. Maybe it's part of some kind of mechatronic robotic system, or a system that has some kind of sensor, and then maybe some kind of output, like a motor or something like that. And I think there's some kind of wiring going to what looks like either a Raspberry Pi or an Arduino or something like that. So a microcontroller board. There's also a PCB over here, which has some kind of soldered-on components, which could be anything from resistors to ICs to maybe some kind of transceiver like for Bluetooth or something like that. And there's also power supply coming in here, and also what looks like a signal coming out of the board over here to connect to another device. So my question is, how would you go about taking something like this and building algorithms around it? How do you mathematically model something like this? Let's actually start with step one. We need to figure out exactly what these different things are. And maybe we don't have enough information from these pictures, but we can kind of guess. This thing here looks like some sort of electrical outlet, so I'm guessing that this is where power comes in, and then this is where it goes out. So this is a positive and negative. Maybe it's just ground depending on what the voltage is, but I'm gonna guess this is positive and negative. These two connectors look like they're for some kind of DC power jack. This one here looks like a micro USB, and this one looks like it could be USB-C or micro USB. This connector here looks like it's for some kind of sensor cable. This is not a standard size, so I'm not sure what kind of sensor this is. Could be an environmental sensor, could be a light sensor, could be an ultrasonic distance sensor. It could be a whole bunch of things. So this one I'm gonna guess is some kind of sensor of some type. This port here looks like it's for Ethernet, so maybe there's internet connectivity going on here. This port here looks like it's for USB, so it could be USB-A or B or something like that. And this port here looks like it's for HDMI. So there's a lot of ports here. There's a lot of stuff going on here. Now next we have to ask ourselves, what is the goal of the system? What is this thing trying to do? Unfortunately, based on these pictures alone, it's impossible to know. However, I can make a few guesses. One thing that we can tell is that this is a fairly small form factor setup. It doesn't look like there's any kind of battery pack or anything like that. So I'm going to guess that this is plugged into wall power, and therefore it's not an IoT device, because if it was an IoT device, it would need some kind of battery. So I'm going to guess that this is not an IoT device. Maybe it's some kind of prototype. But because it has a micro USB port, it probably uses USB communication. So I'm going to guess that it probably communicates through USB. There's also this Ethernet port, so it might have an Ethernet connection. And then there's the HDMI port, so I think this is likely some kind of display of some type. And then this is a small form factor, PCB. It looks like it's been soldered onto the main board, so I'm gonna guess that this is some kind of interface circuit board. So it interfaces with the sensor over here, and it sends some kind of signal to the main board over here. So it's probably sending some kind of voltage or some kind of electrical signal. So what is the overall objective of the system? Again, it's difficult to say. It could be something simple, like a digital picture frame, right? It could be something really simple like that. Or it could be something more complicated like a smart mirror. Either way, we're going to guess that this is some kind of display, and it shows some kind of image based off of the sensor readings, and maybe it controls some kind of other device based off of user input. Let's assume that the sensor is an ultrasonic distance sensor, and it gives us the distance from the sensor to an object. Let's say the goal is to display some kind of image depending on the distance. So if the distance is less than 10 centimeters, it shows one image. If the distance is greater than 10 centimeters, it shows a different image. Now let's go ahead and build a mathematical framework for this. So first we have the sensor equation. If we're using an ultrasonic sensor, the way it works is we send out a ping, and we wait for the echo to come back. We measure the time it takes for the echo to come back, and we calculate the distance. The equation for that is distance equals the speed of sound times the time divided by 2. Speed of sound in air is approximately 343 meters per second per. Our analog to digital converter, which is built into the Raspberry Pi or whatever microcontroller we're using, will output a value between 0 and 1023. That'll give us the distance in volts. Now we have our decision logic. So if distance is less than 10 centimeters, we want to show image 1. Otherwise, we want to show image 2. So now we have a decision tree here. If the distance is less than 10 centimeters, we do something. Otherwise, we do something else. So now we can move on to the control algorithm. In this case, we're assuming that we're controlling some kind of servo motor or something like that. So if we want to do some kind of real-time adjustment, we can use a PID controller. PID stands for proportional, integral, derivative. It's a very common algorithm for controlling systems. So the equation for a PID controller is U of t equals Kp times E of t plus Ki times the integral from 0 to t of E of tau d A tau plus Kd times the derivative of E of t with respect to t, where E of t is the error, which is the difference between our desired value and our measured value. U of t is our control input, which in this case is the PWM signal to our servo motor, and Kp, Ki, and Kd are our PID gains. So now we have a PID controller, so now we can design the overall algorithm. So let's use pseudocode to design the algorithm. So we have our main function. Inside of our main function, we're going to call our read sensor function, which will give us the distance from the sensor. We're going to store that in a variable called distance. Then we're going to use our decision logic. If the distance is less than 10 centimeters, we're going to do something. Otherwise, we're going to do something else. If the distance is less than 10 centimeters, we're going to call our showImage1 function. Otherwise, we're going to call our showImage2 function. And then we're going to call our runPID function, which will take in the distance as an argument. So now we have our algorithm. Now let's go ahead and fill in the details. Let's define our read sensor function. In this case, we're assuming that we're using an ultrasonic sensor, so the function will return the distance in centimeters. Let's define our showImage1 function. In this case, we're going to use the OpenCV library to show image 1. Let us define our showImage2 function. In this case, we're going to use the OpenCV library to show image 2. Let us define our runPID function. In this case, we're going to use the PID library to run our PID controller. The input is the distance in centimeters, and the output is the PWM signal for our servo motor. This has been part 1 of a multi-part series on mechatronics and control systems. In this video, we covered the basics of modeling and algorithm design. In part 2, we'll dive deeper into the math behind PID controllers and how to tune them. Make sure to subscribe so you don't miss it.